Today we're going to look at linear programming, which is actually a class that you can take an entire class in college. And so I'm only going to do one lesson here, but you get the idea that this could actually take up quite a lot of learning. Go ahead and pause and write down all this vocabulary. I'll be looking for those in your notes. So in the vocabulary we have optimization, which means that you're finding the maximum or the minimum value of something. And linear programming is the process of optimizing. Your objective function is the equation that you're finding the minimum or maximum of, and we'll see that on our examples that we're doing, you're going to see a C equals blah, 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 blah. And that's our objective function that we're trying to find the biggest and the smallest. Constraints are the linear inequalities. We'll be graphing those, and those will help us find the maximum and minimum. And then the feasible region is after we've graphed them. I would like you right now to hit pause and look up on page 163, the Investigating the Optimal Solution box. If you don't have your book with you, you're going to have to look this up then in the morning. I want you to have looked at it before class tomorrow. Alright, so here's an example. We're going to find the minimum value and the maximum value. Oh gosh, I've forgotten the name again. But anyway, that's the equation that we're going to be using to find the biggest and the smallest. And below are the constraints that we will be graphing to find that. And so what I'm going to do is I'm just going to make this nice and big so that when I do graph it, we can easily see and graph. So we start with x is greater than or equal to 0. And so I go to the x-axis and I pick, go to the x-axis and I pick points where it's on 0, so that's basically the y-axis. And so I draw my line going down the y-axis, and it's going to be shaded to the right. Alright, then I look at my next one, which is y is less than or equal to 2x plus 2. So if I change my color here, let's go for some purple. I cross at a positive 2, and my slope is 2 over 1. Now it says that y is less than or equal to, so I can draw a solid line here. Sorry, I don't have a ruler. Okay, so I draw my solid line, it's less than or equal to, so now it's going to be shaded in here. And we'll go down that way, but remember I'm restricted on the y-axis there. And then for my last one, I have to do a little math here. So let's go with a red. I'm going to move the x over. So I get negative x plus 5 is greater than or equal to y. So my y-intercept is 5. 1, 2, 3, 4, 5. And my slope is negative 1. Let me move back over here. My slope is negative 1. So we see where those intersect. Okay. Keep on going in that fashion. And then to shade, it says y is smaller. So if I go back here, I'm going to shade below. And so now if I look at this from here to here, and straight down, and I've got the slant right here, and then if I shade, it actually goes on forever and ever this way. So when I'm trying to find my min and my max, remember what we're looking at. We're looking at our vertices, and that's what's going to give it to us. So if you looked, hopefully you did your homework, and you looked at that page 163, and you saw that it doesn't matter. We're not going to go in the shaded area here. That's not going to give us a min or max. On the line is not going to give us a min or max. The big deal here is going to be the let's see here, let me pick a good color here, I guess we'll go with green. It's going to be these vertices here where the graphs intersect. So it's going to be this point right here, and it's going to be this point right here. And nowhere else do they intersect. In fact, if I look down here at all these spots down here, it actually keeps on going. So this point up here is going to be the point x is 1 and y is 1, 2, 3, 4. So that's going to give me something. And then this one here, x is 0, y is 2. So for these 2 points here, I'm going to take those and plug them into that C equals equation. And let's see what happens if I do that. Okay, so we can make this smaller again. Now our objective function was C equals x plus 5y. we have 2 points that we're going to try out. We are going to try out 0, 2, and we're going to try out 1, 4. So I'm going to take both of those and plug it in for x and y. So in our first one, we're going to get c equals 0 plus 5 times 2, which gives me 0 plus 10, which is 10. Then I'll try it again for 1 and 4. So I plug in 1 for x and 4 for y, and we get 1 plus 20, which gives me 21. Now normally what I would say is that 21 is my max and 10 is my min, because one of them is bigger than the other one smaller. But if you remember, this graph goes on forever and ever, right? This keeps on going in this direction. And so I can keep on getting smaller and smaller numbers. And so I'm not actually going to have a min on this one because I can get smaller and smaller numbers there. So I am only going to have a maximum because my point 1, 4 is as high as it goes there. So 21 is my max, so I'm going to circle it and label it as max. And then I'm going to say that there is no min. And that would be my answer right there. Next page. So here we go again, another example. We have a different equation here, c equals negative x plus 3y. And this time we actually have 4 constraints. So we'll graph all of those. Let me make this bigger so I can graph it pretty easily. I have x is greater than or equal to 2. So I find 2, x is greater than or equal to, so I'm going to draw my solid line. And x is greater than or equal to, so it goes this way. And then I go to my next one, x is less than or equal to 5. So I'm just going to stay in green there, 2, 3, 4, 5. So I've got another vertical line, and it says it's less than or equal to. So it's going to be somewhere in between these two green lines here. Something in between those two. And my next one says that y is greater than or equal to 0. Again, I think green will work just fine. So that's going to be the x-axis this time. And now that's going to be bringing it straight up. So far I have this tube starting at the x-axis going straight up. And then I have y is less than or equal to 2x plus 12. So that's going to give me a little bit more to go off of here. In fact, this only goes up to 10, so I have to kind of tick this off, 11, 12. And then my slope is 2x, negative 2x. So I go down 2 over 1. Down 2 over 1. So there I've made an intersection point. Down 2 over 1, down 2 over 1, down 2 over 1, another intersection point, down 2 over 1, and down 2 over 1. I think that'll be far enough. I'm going to go back to the equation. It says that it's less than or equal to, so I got to do a solid line connecting these points. Not bad. Alright, I'm going to go through it again just to make it a little bit more solid. And then it says it's less than, so I'm going to shade below. So I've got this, I don't even know what to call it, but this weird shape here. Now once again, we have to look at, to figure out our max and min, we have to look at where do all of these intersect, where are our intersection points. So let's make it bigger so we can look at this more clearly. I actually have 4 points here. Let me get out the red pen to show you. So we have this first one right here, which is x is 2, y is 0. And then we have this one right here, where x is 5, y is 0. And we've got this one. This one, x is 5, y is 2. And lastly, we have this big one over here, where x is 2 and y is 1, 2, 3, 4, 5, 6, 7, 8. So I have 4 points to plug in and try to figure out my max and my min. And this time I will have both max and min because it is enclosed. It's when it goes on forever in one direction that you don't have one or the other. So let's see here. I've got the point 2, 8 to try. I've got the point 2, 0 to try. Then I have 5, 0. And I have 5, 2. So I have to try all of these into my equation here, c equals negative 8 plus, or negative x plus 3y. So let's see what we get. We're going to have a negative 2 plus 3 times 8 is 24, gives me 22. That's pretty big. Then I have a negative 2 plus 3 times 0 is 0, gives me negative 2. That's pretty small. Then I have a negative 5 plus 3 times 0 is 0, so it gives me negative 5. So I know negative 2 is not going to be either one because it's in between the two. And then I have negative 5 plus 3 times 2 is 6. That gives me 1. So what I'm looking for is my biggest number here, my smallest number. My biggest number is 22. So 2, 8 is going to be my maximum. And then my minimum is going to be 5, 0, because negative 5 is my smallest number. So there's my minimum. And it's fine if you do it that way, where you just highlight or circle off your point and then the actual number of the max. And then label it. You need to make sure you tell me whether it's a max or the min.